ground level carries a net load intensity of 150 kilonewton per meter square. If a compressible clay layer 3 meter thick exists at a depth of 5 meter below the footing, determine the settlement of the footing due to the consolidation of the clay layer. Assume the water table at a depth of 3 meter below the ground level, and for sand, density is equal to 18 kilonewton per meter cube above water table and 19 kilonewton per meter cube below water table. And for clay layer, liquid limit is equal to 65%, water content 40%, and specific gravity 2.7. Take gamma W as 10 kilonewton per meter cube. So let's draw the figure firstly. So this is the question. A ground level is there, a footing is there which is at a depth of 2 meter from the ground level. Okay, and a compressible clay layer 3 meter thick exists at a depth of 5 meter below the footing. So we have to draw a compressible clay layer of thickness 3 meter. This is a clay layer. It is below 5 meter below the footing. Now we have to determine the settlement of the footing due to the consolidation of the clay layer. So assume the water table at the depth of 3 meter below the ground level. So we have to draw water table which is below 3 meter below the ground level. Okay. So here this distance is 1 meter, right? And for sand, so below there is a sand layer which is having a gamma unit weight 18 kilonewton per meter cube above water table, and gamma of the sand below water table is 19 kilonewton per meter cube. And for clay layer, gamma is not given, but it was said that for the clay layer, liquid limit is given. Liquid limit is equal to 65%, water content is equal to 40%, and G, value of specific gravity, is 2.7, and it was asked to say gamma W as 10 kilonewton per meter cube. Okay, so first we all must know about the equation for settlement. What is the equation for settlement? SF is equal to Cc by 1 plus E naught, or 1 plus E into H naught log to the base 10 sigma 0 plus delta sigma 0 by sigma 0. Okay, so first we must know Cc, H naught, E naught, sigma 0, delta sigma, and okay, these all values should be known. Okay, so what is Cc? Cc, we can calculate Cc by using equation 0.009 into liquid limit minus 10. Okay, here clay layer liquid limit is already given, so you can calculate Cc value as 0.009 into, here liquid limit is 65%, so 65 minus 10, which is coming around 0.495. Okay, so Cc is known. Now we must find out void ratio, E. So we all know there is an equation ES is equal to W into G. And so for clay layer, since it is below the water table, it is in a saturated condition. So value of S is 1. So here E into 1 is equal to W into G. So E is equal to W into G. Value of the water content is 40%, so 0.4 into 2.7 is the specific gravity. So the value of E naught is coming around 1.08. Okay, so this is the void ratio, E or E naught. Now we must know, we have to calculate sigma 0, stress and change in stress. So for that we must know the gamma sat value of the clay layer. This gamma is known, but here we don't have gamma sat value. the clay layer gamma is now given. Instead, they have given many other values. So we all know there is an equation for calculation of gamma saturated unit weight of any soil, that is G plus E by 1 plus E into gamma W. So we have all the values. G is 2.7, E is 1.08. So 1 plus 1.08 into gamma W is asked, we are asked to take it as 10. So this value is coming around 18.2 kilonewton per meter cube. Okay. So gamma set values no. Now we can directly calculate sigma 0 initial stress. So what is initial stress? Initial stress is a vertical stress that is developed due to the soil. Okay. So we have, I'm just drawing this figure out there here. Okay. Here we have 3 meter thick with gamma value 18. Then we have a water table layer. Then gamma value 90 with this depth as, if this is 5 and this one is 4, this depth is 5 minus 1, which is 4 meter. Okay. So this one is 4 meter. Then clay layer of 3 meter thick with the gamma sat value as 18.2. Okay, so now we can calculate the gamma 0, that is 18 into 3 plus 19 into 4 plus 18.2 into 3, which is coming around 184.6 kilonewton per meter square. So this is the gamma, sigma 0. Now what is change in stress? When a footing is inserted into this clay, into this soil, the additional stress occurred is given in the question, that is 150 kilonewton per meter square. So all the values in this equation is obtained. Now we can just apply all the value into this equation. Okay, so H0 is the thickness of the clay layer, which is 3 meter, right? So SF will be obtained in meter since we are applying all the values in meter. So CC value is 0.495 into H0 is 3 divided by 1 plus E is 1.08 log to the base 10. Sigma 0 is 184.6 plus 150 divided by 184.6. Okay. So SF is coming around 0.18 meter, which is 80 centimeter. So the settlement due to this footing when the clay layer settle is 80 centimeter.